recording. Okay, so today we're going over basic probability. So probability is the number of desired outcomes divided by the total number of possible outcomes. So this, you might not understand what this means, but we will be going over a problem just to demonstrate what this could mean. Okay. So, superhero Sam spins a wheel. If it lands on red, he will defeat an evil dragon that is robbing the bank. If it lands on blue, he won't be able to defeat the dragon. So, what are the chances of Sam defeating the dragon? So, okay, so some of you may know how to do this. If you do, then private message me what do you think the answer is. If you don't know how to do this, then I will go through and explain this problem so that you do know how to do it. But basically, the total number of desired outcomes. So the total number of desired outcomes are where he would defeat the dragon. So if he lands on red, right? So that would mean that there are, so in probability, we divide everything into equal parts, which basically means that everything has an equal chance of occurring. So that would mean that we would have to divide this up like this and like this, right? So it's divided into fourths, right? So we are dividing it into fourths so that we have 1, 2, 3, 4 total parts that are equal in size, which would mean that they have an equal probability of occurring, or like an equal chance of landing on any part of them, right? So that would mean that the total number of parts is 4, and the total number of like wanted parts, the total number of desired outcomes would be 3. So 1, 2, 3. So that would mean that the chances of Sam defeating the dragon are 3/4. So yes, I see in the private answers, a lot of you all put their 3/4 or 75%. 75% is equal to 3/4 because if we did 3 divided by 4, that's 0.75. So good job. Also, can we not write on the screen? Okay. Okay. So, okay. So you roll a fair six-sided dice. What is the probability that the die lands on a prime number? So I will let you all do this one. And private message me what you think the answer would be. Okay, so I am seeing a lot of answers coming in. So let's first list out what the total number of possibilities are, right? So we know it's a six-sided dice, which automatically means that it's a fair six-sided dice, meaning that our choices are 1, 2, 3, 4, 5, 6. And earlier we looked at the area in order to see like which ones, like in order to see, make sure that everything had an equal likelihood of occurring, right? But when we say it's a fair six-sided dice, that means each chance or each outcome has an equal possibility of occurring. So that would mean that each of these has an equal possibility or probability of occurring. So what's the probability a die lands on a prime number? So you have to know what a prime number is. A prime number is any number that has exactly 2 factors, right? So that would be any number that has both a factor of 1 and itself. And if it's 1, it's not a prime number because 1 only has 1 factor, right? So a prime number has 2 factors. So that would mean that our prime factors are 2, 3, and 5, meaning that the total number of desired outcomes are 3, while the total number of outcomes is 6, right? So that would mean that the probability is 3 over 6, which is equal to 1 over 2, which is 1/2, or 50%. So I see some of you got that. Some of you put 4/6. I believe that you thought that 1 was a prime number. So remember, 1 is never a prime number. Iksha, you have a question?
Can you repeat what you said that when you explained the problem? My audio.
Do you want, okay, I'll just repeat the whole thing. So we want to find the total number of desired outcomes over the total number of outcomes, right? So there are 6 outcomes, 1, 2, 3, 4, 5, 6. And because we know that it's a fair die, that means each of these has an equal likelihood of occurring. And that matters because when we're looking at the total number of outcomes, we're looking at like the total number of equally likely outcomes. So that's what we mean when we get this denominator, right, as 6. And then our numerator is the total number of desired outcomes. So these would be all of the prime numbers, right? What's the probability the die lands on a prime number? So that would mean that since prime numbers are numbers that only have 2 factors, that would mean that we would only look at 2, 3, and 5 as our desired numbers or desired outcomes, which is 3 possibilities. So 3 over 6 is our answer, which is equal to 1/2, which is also 50%. Do you need me to explain anything again?
Yeah, I got it. Thank you.
Okay, you're welcome. Okay, let me clear my annotations. Okay, so, okay, next problem. So next thing you need to know. So some basic information that you should be aware of is that a deck has 52 cards. So this matters because that would mean that each card that you draw, right? If we are looking at a deck of cards, right? If a problem tells you there's a deck of cards, then you have to remember that there are 52 cards and there are 4 suits, so spades, clubs, diamonds, and hearts. And each of these 4 suits has 13 cards, right? So it's 2 to 10. And so it's ace. Well, the 13 cards are ace, 2, 3, 4, 5, 6, 7, 8, 9, 10. And then jack, queen, and king, which is 13 for each suit. And yeah. And then that's what we need to know about a deck of cards. And a die, unless otherwise specified, has 6 sides numbered 1, 2, 3, 4, 5, 6. So if a problem says that you roll a fair die, right? You assume that it only has 1, 2, 3, 4, 5, 6 as possibilities. Otherwise, you if some other information is given, like it's not a fair die, or there are like it's a four-sided die, so like a tetrahedron, then we would assume otherwise. But if we don't know anything else, we assume that each of the sides has an equal possibility of occurring, and those sides are 1, 2, 3, 4, 5, 6. And then a coin has 2 sides, a tails and a heads. A fair coin has a 50% chance of landing on each side, and most of the time you will see problems that just, if they talk about a coin, we assume it's a fair coin, meaning that both sides have an equal likelihood of occurring. So you might want to write this down. So I'll give you all like a few seconds, like 30 seconds-ish. But this is important information that you should know if you're competing in math counts or any other competition, because sometimes you are not necessarily explicitly given this information, but it is there. Okay, I am assuming you all wrote that down. Okay, so now that we have covered what finding the probability of one event would be, we are going to talk about independent events. So independent events do not affect the probability of each other. So if Biden decides to drink coffee tomorrow and the King of England decides to drink coffee the day after, these two events are not impacting each other, right? So that would mean that they are independent. So if I were to draw a card out of a deck and toss a fair coin, then no matter what card is drawn, it doesn't affect the outcome of the coin, right? So the probability of spinning a specific color on a color or on a wheel or rolling a dice, for example, as another example, would not impact each other. Okay, so if you want to find the probability that two different independent events occur, then you multiply the probabilities of these two events. So this might also seem a bit confusing, so we are going to go over a problem. Okay, yeah, I can go back to the basic info section after we do this problem. Um, okay, so say there is a 50% chance of rain on Sunday and a 30% chance of rain on Saturday. What is the probability it rains on both days? So we assume that these two events are independent because of the fact that we are not given any information that says other. So if you know how to solve this, then you can go ahead and private message me your answer. Otherwise, um, I will solve it. And yeah. So there's a 50%. Okay, so we are trying to find the probability it rains on both days. So that would mean we're trying to find the probability of event A, which is so 50% chance of raining on Sunday is event A, and event B would be a 30% chance of rain on Saturday. So okay. Um so so this is event B. So what we want to do is multiply them together because we know that we if we multiply them together, we want to multiply them together because they are independent events, right? And we want to find the probability of both of them occurring. So 50%, so we could do this as 0.5 times 0.3, or we could do it as fractions. It doesn't matter how we do this, but the probability of the first event, event A occurring, sorry, let me write A. The probability of event A occurring is 1/2, according to the information that we are given, and the probability of event B occurring is 30%, which is 3/10, according to the information we are given. So that would mean that we want to multiply them together in order to find our answer. And I'm sorry if the yellow is a bit hard to see. I can rewrite it after I write this out. So okay, we can see that we have to multiply these together. So that's 3/20. If we were to express this, it asks us to express it as a fraction, which is 3/20. However, if it did ask us to express it as a percent, for example, then we would convert this. So percent just means out of 100, right? So 3/20 is 15/100, which is equal to 15%. So 15% is not the answer. It should be 3/20 because it says to answer as a fraction. Okay, so I see like only a handful of you got it correct. Some of you just kind of averaged it out. In probability, we aren't averaging. We will not average out independent events. So yeah. Okay. Let me clear all my drawings and yeah. So when events are independent, you can use the fundamental counting principle. So fundamental counting principle is basically probability of event A and probability of event B is equal to A times B, or probability of A times B. Okay, so now we're going to go over dependent events. If two events are dependent, that means that the events are not independent, meaning that they do impact each other. So if I were to pull out so say for example, I had 3 marbles in a sack, right? To make it, so say that we had 3 marbles in a sack and I pulled out one of them and I did not replace it. Then I had to pick out another one. That would mean both events impact each other since we changed what we originally had, right? So what we choose in the first event changes what the possibilities are for the second event. So another example is if I were to pull one card out of a deck and it's an ace, and I pull out another card without replacement and it's another ace, right? The probability of this occurring, the probability of both of these, right? These two events are dependent on each other, right? Because normally there would only be a 1/13th probability of pulling out an ace, but then this reduces if we were to take out a card without replacement to 1/17. Yes, you raised your hand, Iksha.
I don't understand how it becomes 1/17th or 3/50.
Okay, so in a deck of cards, we have 52 cards, right? But if I were to pull out a card from this original deck, then that would mean, and it is an ace, then that would mean that there is one less ace in the deck, right? So originally there are 4 aces in the deck, out of 52, but now because we've taken out one card from the total, the denominator is 51, and because we have taken out one from the number of aces, that is equal to uh that is equal to 3, because 4 minus 1 is equal to 3. Does that make sense? Okay. Okay. So basically, if one event impacts another, they are dependent. Okay, so a practice problem. So out of 18 girls and 14 boys, 2 kids are randomly picked to feed the class hamster for a week. What's the probability that both kids picked are girls? So, okay, so some of you may know how to do this, some of you may not. But if you do know, remember, private message me your answer. Otherwise, I will start explaining. Okay, so the probability that the first kid picked is a girl is so we have a total of 32 kids, right? Because um 18 plus 14 is equal to 32. And then of those kids, we have 18 as girls, right? So that means the probability of the first person being a girl is 18 out of 32. The probability that the second person picked as a girl is one less than this. And that is because, it means like we have 17 girls now, right? Because the first one picked was already a girl, right? So that would mean that we have 17 as the total number of desired outcomes, and we have 31 as the total number of outcomes, right? So so let's try to simplify this a little, right? 18 is divisible. 18 is divisible by 2, so is 32. And that would mean we get 9/16 times 17 over 31, which is equal to 153 over 496, right? So I'm actually going to change the numbers for this equation because that is probably a bit hard for you all to understand. So let me quickly. Okay, so I am going to change the numbers. So say that we have out of a class of 5 girls and 4 boys, 2 kids are picked to feed the class hamster. What is the probability that both kids picked are girls? So now you all do this on your own. And if you don't know how to do it, remember you can private message me in the chat in order to let me know that you need me to explain something. So a lot of you have not responded. Make sure you're responding in the chat. If you don't know how to do it, that is fine. But like, yeah. And also remember, private message me.
I have a question.
Yes.
Totally unrelated to this topic, but I missed the class on October 8th. Is there any way I can still access the lesson?
I believe these slides should have been posted, and same with the recordings. Although I don't know if I was the one who recorded them. If I am not, I can ask the teacher who was the well, actually you probably don't know. But I will make sure that we upload that, and I'll
Oh
make
wait,
sure the slide.
upload it where? Upload it where?
It'll be on our YouTube channel, and we will also put it on the Google Classroom. So
What's the code for the Google Classroom?
I can give it to you at the end of class. Just stay
Okay.
after for a few minutes, and yeah. But we can. I can help you with that at the end of class. Okay.
Okay.
So yeah. Okay, so back to the problem. So out of a class of 9 kids, right, we want to randomly choose 2 people who are girls, right? So we have a total of 9 as the total number of outcomes for the first kid, and 5 of them will be girls. And then we have a total number of 4 girls after we remove 1 out of 8, right? So 4 over 8 is equal to 1 over 2, right? So that would mean that this is equal to 1 over 2. So 5 over 9 times 1 over 2 is equal to 5 over 18, which is the answer that you should have gotten. And some of you okay, well, some of you did get 20 over 72. Remember, you should be simplifying your fractions, whatever they are. And okay, I believe someone in the chat. Okay, does anyone have any questions about this? Because, yeah. Okay, so I'm assuming that means that you all do not have any questions. Okay, so okay, so you draw a card out of a deck and draw the second card without replacing the first card. What is the probability that both are face cards? So remember, the information that you had to remember was that there are 52 total cards. There are 4 suits, spades, clubs, hearts, and
Diamonds.
diamonds. Yeah, sorry. Yeah. So usually you don't have to remember the suits because if they matter, they're given to you in the problem. And then you also have to remember that the face cards are there are 3 different types: kings, queens, and jacks. And then oh yeah, half the deck is black, the other half is white, or not white, is red. So that's all the stuff that you need to know. So given all this information, um, uh, try to solve the problem. Okay, so I see only two people have answered, so I'll give you all until 7:38. If you do not know how to solve it, then that is fine, but tell me in the chat so that I know that you're at least here and you're trying, but you might not necessarily get um what how to do it. Okay, it's completely understandable if you don't understand, but if you do not understand and you do know that there's something specifically that you have a question with, you can type your question in the chat to me, or you can um, uh, like ask it out loud, right? Unmute and ask, because maybe someone else has the same question as you and just doesn't know how to phrase it or doesn't know that that's specifically what they're struggling with, right? So, um, okay. So okay, I see a few answers, but I also see quite a few people who don't know what to do. And again, as I said earlier, it's perfectly fine if you do not know what you have to do, but please ask a question, right? So, okay, someone said they don't know what numbers to multiply. So when you are doing this, right, you multiply the probability of the first event, right, which is the probability of uh drawing a card out of a deck that is a face card, right? So okay, so let me type this out. The first event is the probability that the first card is a face card. Um and then the second event um is the probability second event is the probability that the second card pulled is a face card given um okay, given that we don't know um okay, given that we don't know sorry, not given that we know, given that we know a face card has been pulled out in the first event, right? And this would be equal to okay. So the probability that the first card is a face card times is the first event, and the second event is the probability that the second card is a face card. So what we want to do is we want to multiply these two together, right? So the probability the first card is a face card is there are three. So remember that we have three different types of face cards, and that each of these corresponds with 4 suits, meaning that there are 12 total face cards. So like a king of spades, a king of clubs, a king of hearts, a king of diamonds, a queen of spades, a queen of clubs, a queen of hearts, a queen of diamonds, a jack of spades, a jack of clubs, jack of hearts, and jack of diamonds, which is 12 if you count it out if you count it out, right? So 12 out of 52 multiplied by, and then we've already this is the probability of the first event, right? And the second event is the probability of the probability of the second card being a face card. Right, given that we removed one of the cards from the okay. Let's just not type in the chat unless we have a question or if we're answering the question or answering some other person's question. Okay? Try to be on task. Okay. Oh yes, sorry. The probability that they are both red face cards. Sorry, I misspoke. So there are actually 6 in the total number of there are 6 out of 52, and there is 6 minus 1, which is 5 over 51. Can we not be disrespectful in the chat, please? Like at all. Okay. The probability that they're both red face cards, right? So we can simplify this out, right? So we divide this by 3, and we are able to divide this also by 3, and we get 2 times 5 over 52 times 17 if we were to simplify it out, right? And this is equal to 15 over 1,326 if we were to multiply it out. So a few of you were able to get it, but a lot of you were unable to, or like you didn't understand where to start. And that's totally fine. If it's the wording itself that is confusing to you, usually questions will be worded like this. If the way I explained the wording of it is like the problem itself, then that's on me, right? You know, I can change the way I explain it, but usually this wording is what you'll be given in the actual in an actual question. Okay. Okay. So does anyone have any questions? If you do, you can private message me in the chat. And if you do not, then that is also fine. Okay. Now we are going to be going over or versus and. So think about it. So if we have a jewelry drawer with 9 necklaces, of which 4 are silver and 2 are platinum and the rest are gold, right? If you close your eyes and randomly grab a necklace, what's the probability that it is gold or it is platinum? So let's just draw out. Oh, the way that I got 6 and 5 in the previous problem is that it was asking for red face cards, right? So we know that half of the okay. So we know that the face cards are king, queen, jack, right? And we know that half of the suits, right? So half of the deck is red, right? So that would mean that there are a total of 12 face cards, of which half of them are red, half of them are black, meaning there are 6 face cards that are red, right? And we're asking about red face cards. So that would mean we get 6 out of 52 as the probability of the first event, and we get 1 less from both the total and desired, which is 5 out of 51. Because we are taking out a red face card, so the number of cards is less, but also so is the number of red face cards. So we got 6 from the fact that, yeah, okay. Okay, so I will clear all my drawings. Okay, so what's the probability that it is gold or that whatever we choose is gold or platinum, right? So I am going to draw out the drawer, right? So we have a couple necklaces. So let's draw them out. So we have 4 silver ones, right? So 1, 2, 3, 4. We have 2 platinum ones, let's just, the color doesn't really matter. And the rest are gold, right? So 4 plus 2 is 6, right? Meaning that of the 9, 6 are not 6 are not gold, meaning that 3 are gold, right? So 1, 2, 3. What's the probability that it is gold or platinum, right? So gold or platinum would be whatever this set would be, right? So that is 1, 2, 3, 4, 5 total, right? So that would mean that the total number of desired or the total number of desired outcomes is 5, while the total number of outcomes is 9. So that would mean the probability it is gold or platinum is 5/9. So a lot of you got that correct. I think some of you may have multiplied something by accident instead of just adding it, and you might have gotten a different answer. But it should be 5/9 because the total number of wanted outcomes are 1, 2, 3, 4, 5. 4, 5. And the total number of unwanted outcomes are 1, 2, or are the 6, 7, 8, 9. 7, 8, 9. So there are 9 total, out of which we choose 5. Okay. And remember, if you do have any questions, feel free to raise your hand or ask a question, unmute, say something in the chat. Okay, so or versus N. If we had said what is the probability that the gold is gold and platinum, then it would be 0 necklaces out of 9, right? Because none of them are a mix of both, or according to the information we are given, right? But because we are asked for or, that means that what we're looking at has changed, right? We're combining multiple outcomes, whereas in and we are seeing what the intersection of those outcomes is. So a Venn diagram can help show that. So in a Venn diagram, if we were to use and, like event 1 and event 2, right? Okay, my computer is laggy, so sorry about that. So if we were to use event 1 and event 2, right? So this would be and, whereas for the other one, it would be or, right? So and versus or. And while it might not sound like a huge difference, right? When we look at the Venn diagram, we can see that in most cases, it will usually have a different outcome, depending on what we are asked. Okay, so a practice question. You randomly draw a card from a standard deck and randomly choose a letter of the alphabet. What is the probability the card is read or the letter is a vowel? So first, let's look at it. It says or here, right? So we are going to, yeah,
Wait, I have a
yes, go ahead.
question. Are we gonna count Y as a vowel?
No, we are just gonna do
Okay.
A-E-I-O-U. Yeah, okay. So I will go over this problem, and if you do have any question, or if you don't know how to do it, that's fine. But if you do know how to do it, private message me what your answer would be. Okay, so you randomly draw a card from a standard deck and randomly choose the letter of the alphabet. What's the probability the card is read or the letter is a vowel, right? So, okay. So our first event is that the card is read, and our second event is that the letter is a vowel, right? So we want to look at our Venn diagram, right? So our Venn diagram would show that we had one event and then we had the other event. And right now we are looking at what the total is, right? Because we are looking at or, right? So we want to find out what the entire region would be. So what this whole thing is, right? So the probability that the card is read is 1/2, right? So we have 1/2, and then the probability that the letter is a vowel is 5 out of 26, right? So normally we would add these, but if we are to add them, then this intersection over here, right, gets counted twice. And we don't want to count the intersection twice because that would mean that we are overcounting, meaning that we are counting more than we want to, right? So now I am going to subtract this overlap once so that instead of counting it twice, we are only counting it once, right? So the overlap is what we were to get if we were to multiply these together, right? So 1 over 2 times 5 over 26. And I know that quite a few of you had questions about the previous problems or like we're struggling a little bit. So if this does not make sense to you, please ask me questions. Please tell me you don't understand what to do, right? There are 23 of you. Yeah, Advait, you raised your hand.
What do you mean by intersection?
So the intersection in this case would be the probability that the card is read and that the letter is a vowel, right? Because we would count that case in or those cases and if the card is read, but we'd also count those cases when we're looking at if the letter is a vowel, right? Because there is a world in which we can pull a red card and have a vowel, right? So because it's counted when we count both the card is red and that the letter is a vowel, we don't want to count it multiple times, right? We only want to count it once. So because we're counting it twice, we only have to subtract the intersection once to remove one of those times we're counting.
Could you explain that again? I don't really get it.
Okay, so I'm actually going to use a simpler problem, right? So say for example, we were to look at if like we roll a dice and we want to get ahead, roll a dice and want to get ahead, like and get ahead, get ahead. And then we also are pulling or rolling or sorry, rolling a dice and getting a prime number, getting a prime, and flipping a coin and getting a head. Okay, so say that we are looking at a case where we want to roll the dice and get a prime and flip a head, flip a coin and get a head, right? Or sorry, not and. We want to look at or, right? So we can roll the dice and get the numbers. So let me make a table to show you the possibilities, right? So we can get 1, 2, 3, 4, 5, 6 as whatever we get when we roll the coin. But we can also get heads or tails as the possible coin tosses, right? So there is a possibility that we flip a head and get a prime, right? So that would be this, and this, right? But if we count the total number of ways we can roll a dice, right? Right. So if we say like we can roll a dice and get a prime, right? We solved that earlier and we found it was 1/2. And if we flipped a coin and got a head, that's also a 1/2 probability, right? So that makes it seem like we have a total of 100% as the probability of rolling a dice and getting a prime or flipping a coin and getting a head. But it only seems like that because when we're looking at the probability of rolling a prime, we are looking at the possibility where we flip or roll a 2 and get ahead, roll a 3 and get ahead, roll a 5 and get ahead, and then the possibilities where we roll a tail and get those same things, right? But we are also counting the possibility of getting ahead and a 2, ahead and a 3, or ahead and a 5 when we are looking at flipping a coin and getting ahead, right? Does that, okay, wait. I don't know if that answers your question, but basically we are counting it multiple times. So maybe it'll help if I kind of try to show this visually, but basically this is the possibility of getting ahead, right? All of these are possibilities of getting heads. And then the possibility of rolling a prime would be these and these, right? Which is which we can see has an intersection, right? Of head and 2, head and 3, and head and 5, right? And we'd be counting them multiple times because we'd be counting 1, 2, 3, 4, 5, 6 ways to get ahead, and then 4 ways to get a 2 and a 3, and then sorry, or 6 ways to get a prime, right? And 6 plus 6 is 12. But in order to truly get an accurate representation, we want to cancel out where they overlap, where these events overlap, right? So a head and a 2, a head and a 3, or a head and a 5, right? Which is 3 possibilities, right? So we would subtract 3. Okay, sorry. We would subtract 3 out of 12, right? Which would give us our actual answer. Does that make sense? I feel like it might not have, but
Yeah, I guess it sort of makes sense now.
okay. But basically the reason we are like, okay. Someone in the chat said it doesn't make sense to them. If there's something specific about it that you can say that doesn't make sense about it, then I would really appreciate that because that would make it easier for me to explain. But basically, if we look at this visually, right, if we look at a Venn diagram, there is a place where we can see the, okay, if we look at a Venn diagram, we can see, sorry, okay, sorry. So if we look at a Venn diagram, we can see that there is in fact a place where the two circles will intersect, right? And because we know that there is a place in which the two circles will intersect, if we wanted to find like the total area of this Venn diagram, right? We wouldn't do the area of the circle plus the area of the other circle because that would mean that we are counting the overlap, right? We are counting it twice. And that's not necessarily what the area is because the overlap is greater than 0, meaning that we are counting a portion of it like more than once, right? So we can apply that principle to probability, where we see there are a certain amount of events in one part and there are in one like condition and there are a certain amount of events in another condition, right? So in this case, card is red as one condition and the letter is a vowel as the other. And then we can, if we subtract the overlap, then we are not counting where the card is red and the letter is a vowel multiple times. Does that?
Oh, okay, I get it now. I get it.
Okay. There was someone in the chat who also said it did not make sense. So does this make sense to you? Okay, I will assume it does. Okay, if you do have any questions, please feel free to ask because I am like the entire point of me being here is for you to learn, right? To help you. So I would really appreciate if you did ask your questions when you have them and like try to ask a specific question or ask like about a specific component so that I understand like what you want me to explain. Okay, so back to this problem, right? So the probability that the card is red, so is this one. And then the probability that the letter is a vowel is this one. And then the probability of both, right, where the intersection is this one, right? And we are only subtracting it once because we counted twice, but we only want to count it once, right? If we wanted to count it 0 times, then we would subtract it twice. But okay, 5 over 26. So there are 26 letters in the alphabet, and there are 5 vowels. So A, E, I, O, U. So that is how I got 5 over 26. So yeah. Okay, yeah. And yeah, I'm just gonna draw an arrow between what corresponds with what condition. Right? So the card is red is 1/2. And the 5/26 is that the letter is a vowel. So when we solve this, we get or when we do this, right, we will get 5 over 52 as this part, 5 over 52. And we will probably not be able to get to the blue kit today. Sorry, I did not keep track of time and remember about it. So I'm really sorry about that. But we will do one next class. I'll try to make sure that next class we get extra time to do the blue kit. If that compensates him. So okay, 26 over, or not 26. 28 over 50, sorry, not 56. Okay, out of 52, we have 26, right? So 26 over 52 is what 1 over 2 is equal to. And then 5 over 26 is equal to 10 over 52. Minus 5 over 2 is equal to 31 over 52, which is the answer you should have got. Yeah, it's gonna be okay that we didn't do a look at today, you know. It's not the end of the world. Thankful. Yeah. Okay. Okay, so the answer is 31 over 52, which is what you should have gotten. But also if you didn't, doesn't make sense to you if you did not get 31 over 52. And if it did not make sense to you still, please ask any questions. Okay. I am assuming that the chat indicates that you do not have any questions, so I am going to stop the recording. But